Good evening, everyone. As you know, please everyone in mute so we have good quality and I don't have to go one by one to mute you. The today agenda, as I mentioned, is quite packed. And some of the topic we are going to do just overview because there are a lot of reading, but until I have to point the most important point in natural language processing, which we actually started previous week, talking in the lecture, but the formal reading are in the today, in this week assignment. Then we're going to move to what is cognitive computing. And I'm going to do a short overview of the IBM Cloud in which we start this week to work. First in the discussion and next week as an individual assignment. Also, I'm making an announcement. I need 2 volunteers to start working on the next project, which is week 4 and 5 on before, because these 2 volunteers are going to work with UMUC data and I need to get them started on before so they can complete the work in 2 weeks. The work is in chatbots, which is the application of natural language processing and cognitive computing. One of the applications is chatbot. That is the assignment for the next 2 weeks. And these 2 volunteers, I need someone who already has advanced with assignment 1, has no problem to complete on time, and can start on before. And this is going to be starting with a small assignment with the perspective to convert in something bigger for the capstone project in 670. Also, Linish is going to do overview of what is the Kaggle competition. Already short announcement and the link are posted in the classroom. He is going to give you the instruction. As you understand, this is extra, let's say, out of the assigned course material, but it's very good hands-on experience which you can practice. And in order to stimulate you, I have promised 2 extra points to the best performer in this competition. And you understand, not only for as an intellectual challenge is good, also you can bump your grade from B to an A because 2 points just can make the difference between 88 and 90. So with no more, I'm continuing with this agenda. This week, you are working in the assignment 1, completing assignment 1, using text analysis, using the back of token approach, which we discussed previous week. And you are using the approach of n-gram, stemming, finding word frequency, word cloud, and you already practically see how much you can get with this back of token approach of text mining. So you can get inside, and at the end, I want to see in your report what are the limitations, which in general we know, but you have to tell me specifically what limitation you see in your study, because we know that this approach in general is limited to find insight in the context. We are just finding word frequency and some insight, but when we start to look of this format, n-gram, 3, 4, whatever grams are, out of the context, because in the way you are doing the text analysis for this assignment, you don't pay attention to the context because this is above and beyond simple text mining when we use classification and clustering. So I very would like that in addition to this general limitation in your study, you reflect specifically of the limitation of your study and make suggestions. So this was one of the diagrams we talked previous week. And to make a reference in, we are going to spam in the intersection of text mining with machine learning and computational linguistics, which gives us the small intersection, which is here in some light brown color, natural language processing. Um, when we go further of the natural language processing, when we go to the cognitive computing, we are going to expand to what is concept abstraction, more machine learning, and other area of this diagram which span with another area of knowledge which are not represented of this diagram. Just this is so we understand where we stand in space of knowledge. So part of this, we are going to cover this and the following 2 weeks. So we mentioned in the previous lecture the main challenge in natural language processing are related.
Estoy aquí escuchando la clase.
Excuse me. Please, everyone in mute. I don't want to start putting everyone in mute. Be conscious that we need quality of this event. Put yourself in mute. If you don't want, I'm just going to do this myself at this point, so we don't have. Okay. I can put everyone in mute, but then at the time you want to talk is going to be a challenge. So I prefer to spend a few minutes now. So the main challenge in natural language processing when we want to understand the natural language in the way we as a human understand. And you very well remember from the previous lecture what is the purpose of the natural language processing. The purpose of the natural language processing started 50 or more years ago in fundamental research in university with the purpose to make the computer understand natural language. And when the start of artificial intelligence research started, this was one of the subtopics in artificial intelligence realm is to make the machine understand a natural language so they can interact with a human and they can act as a human. So that is the main goal of natural language processing. And you understand the goal is so ambitious. So in order to get to this goal, fundamental research has been going on in all these 4 areas which I have listed here, which are the main challenging area in natural language processing, starting with the lexical analysis, when the analysis has to identify the part of the speech which are noun, verbs, and after identifying the main part of the speech, which is, let's say, the simplest part of the natural language processing, proceed to what is the syntactic analysis, which is parsing with verb and subject and object of the phrase, identifying the phrase, and the most difficult when we have to go to what is the semantic analysis. The culmination in natural language processing and understanding, if we want the computer to understand the language the same way we as a human understand, we have to be able not only to understand the structure, the lexical, syntactic, and the semantic of the phrase, but also to be capable to infer from the phrase. What that means, natural language processing and understanding goes beyond of this syntactic analysis, which is parsing the phrase, and goes beyond the semantic analysis. The capability as a human to make the machine understand natural language is the inference. What that means? Inference is very human capability of thinking. So when we talk about natural language processing and understanding, we are talking about that we expect that the computer will make Inference, similar, we as a human do. And when we talk about inference, we human do, we think about this process similar of thinking as human. So this is the ambitious task which artificial intelligence 50 years ago defined for what is portion of this, with this natural language processing. So here before proceeding, I want to open a parenthesis. So we are turning back what this has to do with the course Big Data Analytics and why we are doing this in the course of Big Data Analytics. And I'm opening here the parenthesis after is clear how complex is the problem, how ambitious it is, and that we are approaching to what we would like that the computer is capable to do. So turning back to our discussion of the first 2 weeks, we concluded that 80% of the data of big data is unstructured data. And this unstructured data is mainly comprised by textual, visual, and all this complex data of textual data. If we want that the computer get insight for this data, the first thing we have to do is that the computer can understand natural language. Why? Because most of the texts are in form of free text. We were talking about hundreds of examples which are in any industry today, and companies are expecting in insurance industry to get insight, for instance, of claim or policy written document which are in plain English. Also, medical record, medical patient record from the hospital, discharge notice. All these are free text document, and an industry like healthcare, um, insurance industry, also financial industry, human resource department in each company, all the information is free text. Everyone today, the way the technology is moving with the advancement, is expected that very soon computer can help us in understanding and getting insight of this free text data, which is 80% of big data. So that is the reason why in this course we are going to pay a lot of attention to this 80% of data. And in order to get insight of this 80% of data, we need a computer to understand natural language processing. Also, um, I want some observation regarding the discussion week 1 and 2. I'm impressed by the week. I'm very happy the activities are going up to now. Hopefully, it's going to continue the same way until the end of the course, with few exceptions which still are missing the point of big data. So when we talk about the course is 3 words, one after the other altogether, big data analytics. In plain English, what that means. Just talking about natural language understanding as human, we can understand by these 3 words together several different things. When we say big data is portion of this big data analytic, we think about big data as technology. When we think about big data as technology, we think about Hadoop because this was the first technology which helped us to manage big data. But when we put big data with analytics, you understand that here we are talking about the analytical approach for big data. That's why we already with the consensus on what big data is, what is big data technology, we are moving forward in what is how to perform, what are the approaches for doing analytic on big data and analytic on let's say unstructured text data is related with understanding natural language processing. So this is the logical behind what we are doing and why we are doing this. So up to here, if any question, you can unmute yourself before I proceed to the next key point. Any question up to here? Remember that you can put your question in the chat in writing if you don't want to interrupt and let's say interrupt the class, and you don't want to forget your question, not a problem. So going forward, clarifying some point, um, just to put more, to make the case stronger about the challenge of the natural language processing, think about all these issues like how the machine, if we as a human, when we talk about word level ambiguity, syntactic ambiguity, and a further resolution, when we as a human communicate each with other many times, we understand different things. So how we are going to make that the computer understand this, let's say, with all this ambiguity? Let's say, how you understand that this should be somehow part of the process to understand the natural language and has to be implemented in the computer. For us as a human, when we read a phrase in which the word design appear, design can start as a noun and as a verb. And you understand that all these syntactic, we have to pass only not only lexical but syntactic parsing in order to classify correctly the word design is a verb or noun in the expression we are talking about. Just talking about the very simple word level ambiguity. Not to talk about the syntactic ambiguity, which has to do with things like, for instance, how we understand a phrase, for instance, a man saw a boy with a telescope. Is the boy with the telescope or the man saw the boy through the telescope? So you understand this phrase has syntactic ambiguity and is the way the writing language is. So this ambiguity has to be resolved in the computer understanding of the natural language. Not to talk about an Fourier resolution, which is even more complex. You have a lot of example on this. Um, Here I want to point in the most important thing, which is the context, and how the context can go beyond of the given document or of the given instance in which we communicate, where inference and understanding the phrase in the context is paramount. For instance, inference. We rely in previous knowledge to conclude, for instance, conclusion, recommendation. These are very human to think. And what we actually want from the computer when understand the natural language is to think similar like we are human, to draft conclusion, to draft recommendation, because ultimately what is the purpose of analytic? To draft conclusion, to extract knowledge, to give recommendation. These are part of the, let's say, insight we expect from analytics. Then, simple inference, which rely in some knowledge, is we are reading the phrase, for instance, he has quit smoking. We immediately, as a human, can conclude that he's that implies that he smoked before. But think about when a computer interprets this phrase, how the computer can learn all this previous knowledge we have that if someone quit smoking, that most likely means that he smoked before, otherwise has no reason to quit smoking, right? That is the way we as a human infer from our previous knowledge. We make conclusion and even we can make recommendation. That ultimately is the goal of the natural language processing from the analytical point of view, bringing insight from free text data. I think I showed it to you this slide previous week, so I'm not going to spend more time, but just to focus how important it is. Here we are not talking about structured data with 2 columns and 3 rows, which is person organization, and we can match the person with the organization just with the row on the structured table. We are talking about a phrase which is mostly in the way which is to the right hand, and we expect that the computer can make sense of this free text. This is the ultimate goal. So I would suggest um, you overview the and read the silent reading and participate in the discussion like you did in the first 2 weeks, exchange idea, so we can conclude to more, let's say, powerful insight what we are actually looking for in natural language processing from analytical point of view. That is our main goal in this class. Because when you talk about natural language processing in general, many areas of knowledge or application are interested. Here we have to focus not only what natural language processing is, how difficult it is, why we have to do it beside of the approach of text mining you are doing for assignment number 1, why we have to move in many applications from the approach you are doing back of token to natural language processing, which is much more difficult and consequently much more expensive. Although today the advancement in technology, in research, are implemented, and we can actually have access to many of these natural language processing tools using for our application. And we are going to explore some of them in starting this week. So um, I want to move to the next point. If someone needs some question regarding natural language processing, again, the main goal in our class is to understand from analytic point of view what we are looking at in natural language processing. And think about the following. We are not looking about fundamental research in this class, neither in this program. The fundamental research in natural language processing has been going on for 50 years in university and has advanced and stand at very good point. In parallel, technology has advanced and provide, let's say, a reasonable price of the technology to implement the algorithm and method in natural language processing and understanding. And this has evolved. So again, our main purpose here is to understand the application. We are not going to dig inside in deep what is behind the fundamental research and how it is done. Of course, if you are interested, you are more than welcome to continue with the recommended reading and with the additional e-reading which are in the classroom to go in deep. What I'm talking about, what is required for the course, is the application part. So beside this, our next topic is what is cognitive computing, and as a transition from natural language processing to the cognitive computing, I have this slide here which represents the three different period of time of the computer, which was the 40, and then the programmed computing, which is the one which we still are using, which is in the middle. Started with, we are talking about mainframe, personal computer, and so on and on. We are talking about programmed computing, in which whatever action the computer is going to take is programmed on before in certain language, which is translated to the computer language, which is 0 and 1 bits, 0 and 1. So that is the traditional computer, which has been in place for more than 40 years, and we still are enjoying it and serve many of our purposes. Just as technology has advanced, there is very nice convolution right now between what is big data, artificial intelligence, machine learning. They are blending towards different area. And these blends, one of them is what is represented to the left. I would like anyone, if anyone has a reaction to the representation of what is cognitive to the right hand here. Anyone? What is this graphic telling you? Anyone wants to take the take? If not, I'm going to leave this open because we are actually starting the discussion this week, and I expect the same way we convert to something like in week 1 and 2, we convert about what is big data, how the different side of big data, the technology part, the data part, the application part, and how they are related. It's the same thing here, like with this representation to the right, which represent the human brain and the computer brain, and you see they communicate somehow. And the idea of the cognitive computing is a computer which is, let's say, paradigm shift, totally different of the programmed computer we are using today. It is, let's say, is not programmed, is a computer which is not explicitly programmed in Java and C++. Nothing is programmed there, like the traditional computer we are enjoying today. This type of computer learn from experience, like we human learn. Like child, you start learning crawling, walking, talking, understanding outside world, so on and on. So very similar as a human, this computer learn, but learn not we as a human, experimenting, sensing, and interacting with the environment, but interacting with a human, interacting with human expert. The human expert can be from financial field, then the cognitive computer will be trained in the financial field. The human expert can be from healthcare, and so on and on and on. So we're talking about computer which is not explicitly programmed. And how this was possible? This is possible because you understand this is not simple. We're not talking about here about the semiconductor or about this electronic technology. We're talking about the computer architecture, like the traditional computer. You have memory, you have CPU, and you have a program which moves data between memory and the CPU and execute order one by order, and then we have output. Here, this flow of structure is different. How is different? Again, mimic human activity, learn, and then is capable to understand, let's say, phrase like phrase in plain English, understand, produce hypotheses regarding the free text, find evidence, make recommendation, conclusion, something which is very similar to the human reasoning. And the most important thing is can constantly learn, adapt, and give more, let's say, um, more informed conclusion and recommendation. So, and what is the purpose of this cognitive computing? This cognitive computer then can make sense of this 80% of unstructured data which we define in our first 2 weeks. Um, the cognitive computing was possible thanks to the advancement of different fields, like I mentioned before, artificial intelligence, machine learning, and uh, statistical analysis, and put them together to sense, predict, and infer, and think like a human. So that is the main idea behind what cognitive computing is. So you understand, it's totally different paradigm shift regarding the programmed computing. You don't pre-program, you don't know. Actually, before training the computer, we don't know the answer. And the answer is not answer to numerical problem in general, because for numerical problem, we have the traditional computer, the von Neumann computer we enjoy today. It works very well for programmed problem, and many of the numerical problem can be solved quite successfully, although already new computer like quantum computer are launching, but we are not, that is not in our class. This is, let's say, is too much. Is big data class, but this is too much. So we stay only with what is cognitive, because we are interested in the analytical part, and we want a computer which can help us make sense of this unstructured data. So one example of this computer is IBM in 2011 did, let's say, proof of concept of what is cognitive computing, designed for very specific problem, which was the Jeopardy game. So we are not talking about cognitive computer for general purpose, which was Watson, the showcase of IBM in 2011, that won the Jeopardy against two of the best player in this game. Um, I'm saying that this was showcase. This was something which IBM did, um, um, using the accumulated knowledge up to there and the technology available there. IBM used the advancement of natural language processing, and what is university, this was open project and deep Q&A. So IBM put the investment, the hardware, and huge research team to take all the advancement to put them together under this concept of cognitive computing, which is to learn from the human, learn constantly, improved, and give us automatically, let's say, after learning, suggestion, recommendation, and based on huge amount of textual data, which is one of the important things. So um, let's say when they designed Watson for Jeopardy, the task was, let's say, application task was game of Jeopardy. What were the restrictions from computational point of view? The answer has to come in 3 seconds, no more than 3 seconds, and it has to be at least 85% right for the player to win. So that were the restriction, and of course the rule of the game. You know, uh, I think most of you are familiar with this. With all this restriction, IBM just put at that point as a hardware advancement, high performance distributed computing, 3 million only for hardware, just for proof of concept. And I don't know how many million they are not, they are reported differently in different place in research and software. So you understand that this first undertaking was uh, to put together all the advancement on knowledge with the advancement on technology in application like this, which is very attractive actually to proof of concept. After that, what IBM did was to apply this design, let's say, research and design to different area of application, like they started with healthcare, with financial industry, and using all these main characteristic of Watson, which are uh, in jeopardy. The first thing the machine has to do is to make sense about the question. Making sense about the question is a big deal, because you have to understand first the question and then to do hypothesis and to search for evidences for this hypothesis and find the answer. You will think, oh, in 2011 with Hadoop without technology, Jeopardy game was possible to win just having all the data in the cluster, in multi-cluster powerful computer, and just searching. No way you can search and find an answer for Jeopardy game. Moreover, if you know the rule, the questions are posed this way that even you search in millions of documents, you probably are not going to find the answer directly in any of the documents. You will have to make inference like human. You find this, which is that's my hypothesis. This question is asking about a person who lived in 1942. Let's say this is understanding the question, and then searching in thousand million of documents to find with additional evidence from the question which is the most likely answer to this question. And of course, this was not possible given the nature of the game to find, upload all the documents in a computer and doing simple, not simple, the most powerful Google search is not going to find the problem, the question. So we are talking about searching, but in million of textual document by powerful computer, but with, let's say, intelligent algorithm, machine learning, statistical, starting. And here are the main bullet point about what is inside in high level. Let's put it this way, in high level in Watson in general. So you can train this hypothesis mechanism, evidence search, analyzing evidences, and defining the statistical confidence level uh, of this evidence with a given hypothesis. After finding this evidence confidence level, then combine all these evidences, weigh them, and conclude. This is quite a big word when we talk about analyzing huge amount of textual documentation. And of course, the same way IBM did with Watson, they trained Watson many times, because at the beginning Watson was asking, let's say, not the most adequate question. So that means in the beginning Watson was not understanding the question. And the first thing is make sense of the question. How Watson, how the machine can make sense of the question? Well, we as a human, it's not easy to describe how we make sense of the question, but make sense of the question means you define different hypotheses and you look for evidences to support these hypotheses. And when you find the support evidences, you see for the confidence level of these evidences. And then you combine them for the problem, which is you must understand with the reading we have this week, and we will continue on next week 4 and 5, what is behind, what is the power of this cognitive approach of computing and how powerful it is. And if I return again to this representation to the right, which is the cognitive with the human, you will see we are talking about exactly this learning and adapting. You see the interaction between the cognitive computing and the human. And the main idea is many people are claiming that this new technology are going to take job from human. When we talk about cognitive computing, this is well defined, and we are not going to the realm of the powerful artificial intelligence, where we can talk about kind of machine which can take over human. The main idea of cognitive computing, which you can put artificial intelligence, is part of the let's say, advancement which is inside of the design of the mechanism of cognitive computing. But the main idea of AI in cognitive computing is augmented intelligence. So we have the purpose of the cognitive computing is to augment human intelligence. Very simple example I'm going to give now from healthcare, so you understand why we are talking about augmented intelligence. And the main lemma for the cognitive computing, before going to more detail and get confusing, is created by the human, for the human, not to substitute the human, for the human, to help the human. After IBM launched the proof of concept with, I would say, more than $10 million in research, they start the first application in healthcare in something which today is advancing. It's at fast pace, which is personalized treatment in healthcare. Personalized treatment is very expensive, and I would say personalized treatment is even the best, the most, let's say, medical doctor, the most competent medical doctor, the top in the subject, let's say in oncology. In oncology, it's not possible to do this without the help of computer like the cognitive computing. How it works, the personalized treatment. The doctor in the subject of oncology, just when he gets all the result of the patient, one patient, we are talking about personalized treatment. Just from this patient, what he's going to get is all MRI, blood, tissue, name it you, all these analysis, which are images with huge amount of data if you need to put them in the computer so the computer can help you identify some stuff. In addition, regarding this specific, let's say, diagnosis for this patient, they are related thousands of articles, let's say daily, at least in the topic, they are 30 new articles daily. It's just like a reproduction constantly in the field of oncology. So for human being to read and process this amount of article, he would need 10 years. In 10 years, what is going to be the help for the patient? None. So this is not task of reading this 10,000, 20,000 article related with the patient diagnosis by a human. The most intelligent human being will need years to read them. So here is the power of the cognitive computing. You can pull all this textual information to the cognitive computing and training cognitive computing in the subject. He can extract concept from the language and extract the useful information regarding this specific case in 3 minutes. So Watson trained, he ingests all the article related with this diagnosis, ingest this textual information, ingest all the MRI, blood tests, all pre-existing condition of the patient. He's taking drug from blood sugar, whatever pre-existing condition the patient may have, because the treatment is not going to be the same for the different type of patient. And this is exactly the advancement in personalized treatment. So what Watson is going to give to the doctor, ingesting all this huge amount of unstructured textual MRI, all this unstructured data, is going to give, let's say, a couple, three different suggestion of treatment, and is going to say, with probability 75%, this treatment is going to do okay for this patient, and is going to put the evidences based on which Watson concluded this. And then he's going to say with 65% um, probability, this treatment is going to do okay for this patient. And you understand that in medicine, even the doctor cannot say with 100%. It doesn't exist. So all these suggestions with probability and supported with the evidences based on which the Watson suggested this treatment, the doctor read this and make his own treatment, which can be a combination of this. I mean, at the end of the day, the human expert, which is the oncologist, is going to put the treatment, but he gets this burst of help of ingesting and processing and extracting useful information for huge amount of data by computer like Watson, and at the end of the day, he can make the the treatment itself. Any question coming up to here? We are going to talk more about this. Don't worry if you get confused. I have just 2 slides in which I'm going to go very fast. And next week, if needed, we can talk more about this. This is just one example, very simple, what is behind the mechanism of Q question and answer in Watson for Jeopardy, which is the simplest one. Let's say this is the proof of concept. They applied what was the advancement on deep Q&A project, which was Apache Open project with the University of California, and they applied this. So if you do simple, let's say I'm saying simple, the question is in May 1898, Portugal celebrate the 400th anniversary of these explorers' arrival in India. When we are human, read this question, we immediately can say, make sense of the question. What is this question looking for? For a person, like, so how the machine is going to proceed this? How the computer can get to this? If the computer starts searching all available, accessible documentation for keyword match, what the computer is going to, after looking to all available documents, matching is shown here with red, is going to get celebrate, is going to get in May, is going to get the match anniversary, and is going to conclude that the explorer is Gary. Why? Because in May, Gary arrived in India after he celebrated his anniversary in Portugal. And you understand, this supporting evidence has nothing to do with the question. And with simple keyword search, the conclusion was totally wrong. Because it's not about keyword search. It's about deep Q&A, which is quite complicated mechanism to go. very simplistically presented this deep Q&A mechanism, which is, let me tell you, very powerful project which was done and developed by the university before IBM constructed Watson. So it works not in keyword search. It goes in deep in different direction, is doing temporal reasoning, paraphrasing, geospatial reasoning, and you can see that, for instance, for 400 anniversary, which is in the question, it goes through what is this temporal reasoning, and then Watson in the search find a document in which says 27 of May 498. You understand, with temporal reasoning, this is a supporting evidence for the 400th anniversary. And then you have also this paraphrasing, which is statistical paraphrasing with probability, which arrival in can be paraphrased as landed in, which is the green one, and then another direction, which is geospatial, which, for instance, if we talk about India, then Kapada Beach is in India. This is geospatial. And then arrive that the answer is Vasco da Gama, uh, landed in Kapata Beach in the 27th of May, 1498. And this is in a single document. So you understand how many search. This is exactly big data search with mechanism like deep Q&A. I think for today, this is all I wanted to say regarding the topic of study. And if there is question, I will be more than happy to answer. If not, I proceed to the next point, which is what you need to do for week 3. For week 3, I'm going to share what is Bluemix. This is my Bluemix screen. And I'm very happy that everyone in 9041 has signed it already for Bluemix. Everyone is all set to start this week. And this week, what we are going to explore is one part, which is IBM Cloud, and indistinctly you will find many times referred not only by us, but by whatever documentation as Bluemix. So you must understand that this is the same thing. Bluemix is the unmarried name, and now is married is IBM Cloud. Changed the name, but it's the same. We refer to the same thing. So I think when you start here, you will see to the left hand all different category. And if you click just on one, which is, let's say, data analytics, where we are going to work in, you will see huge amount of different services. We are going to work with some of these services. And I want again to warn you, never put a credit card, because when you click here in your account, you always will have the upgrade account, and if you say upgrade, you can be asked for a credit card. Let me tell you, we are using this industry platform, is the same one which industry is paying huge amount of money. It depends of those. Of course, it depends of how much resources they are using, because it's paid by usage, it's not paid by infrastructure. So is the same access we have, just is through academic provided for the university through academic alliance we have with IBM. If you put a credit card, you are not anymore under this type of account. You are going to be treated differently and you will be charged. Just to show you one simple example, when you go to any of the services, let's say we are going to work with this. This is columnar, high performance, blue technology, BLU acceleration. We are going to work with this for stream Stream Analytic at the end. So when you go to the pricing plan for this, for instance, you see that there is an entry level which is free for up to 1 GB. And this is the one we are going to use, because you understand that whatever be by above that, look to the prices here, because this is actually very powerful technology. Uh, what we are going in this course to use for this in this environment is doing project which, from academic point of view, these free resources are totally adequate. We can do a lot of them, so we can understand the approach to deal with big data, because today, as we talked in the first week, the way we do analytics for big data, this is totally different approach today. Everything is in the cloud, and you, as an analyst, you pick up whatever is needed for the task you are going to do, and you integrate, connect different services. You can connect different services from here in post from the task. So this is the training for the today big data analytics. Connect different services in the cloud. And this is exactly what we are going to train you to do in this class. So besides this category, we are going to work a lot of this category. This week we start with Watson. This is actually the same Watson Cognitive. This is not Watson Analytic you did in Data 610. Watson Analytic is totally different. It's business analytic tool. It's not data science tool. Let's put it this way. Here we talk about the cognitive Watson, the one who won Jeopardy game, the one who is trained for different industry application. And here we have different services of Watson to use for free for us. When you see little here, little is not that it's small. Little means that if in 30 days you open the service and you don't use it in 30 days, they will close the service automatically. Why? Because this is optimization of the resources using. If you don't need something for 30 days, like in your home, you don't use these shoes for 2 years, you just give them, right? It's the same thing here. The resources should be used. And until you close the or delete the service, it consumes resources. So little is regarding this. For starting this week, you have to explore at least two different, let's say, for the discussion, at least two different services here. For instance, tone analyzer. What means explore? You go here, you view start with the documentation. You see the restriction you have here, but this is plenty. 2,500 API call for a month. This is too much, and most of you even are not going to do the API. So let's see. What you have to do is read the pertinent documentation so you know what is behind. Not because of the name you imagine should be this, but maybe who did this is something else. So you have to read what is tone analyzer, what it is, based on with, what to expect. After you read this thing, go to the demos, for instance, and you are going to get the first insight of this service. For instance, let's say there are many sample use cases. Even you can cut and paste your own text and analyze. I'm going just to show very fast an email here, which is writing to the team, the sales leader of Northeast region, because the sale went down, and this is the email message he's sending to all the employees. You can go back when you go to your screen and read more, let's say, more in detail what is. It's a very short email, and then we put to analyze with Watson. And I'm analyzing, and here are the results. Sadness and analytical are the tone analyzer. So you have to read what is the tone analyzer, how it classify anger, fear, joy, sadness, analytical. All these things is in the documentation, and you can play and you can find in the context. You can find analytical in sentence level is here, the whole site, or in document level, the whole document level, or tone in the sentence level, why it is classified with probability which is more than 50% or more than 75%. It's actually strong relation. Okay, this is what I'm expect from this part, to share experience, and in addition to share experience about, let's say, about what is cognitive computing, what is Watson, and how it relates to everything. So I went very fast about this part. We are going to clarify any question you may have in discussion. Right now, I'm ready to answer any question, because I actually don't have more. The last thing is to give um, the presentation right to Linish, so he can explain some stuff regarding Kaggle competition. I don't see any question in the chat. Any question verbal? You can unmute yourself and speak if you wish. I don't see any, absolutely nothing in the chat. Not. Okay, how I go back here? Okay. If they are not questioned, Linish, I'm going to give you the presentation right. Maybe they will come with more questions, just thinking. Because I understand it's too much.
Excuse me, Professor.
Oh, yeah, who is?
Yes,
Yes.
for the assignment one, do we have to analyze more than multiple documents, or we can just focus on one lengthy document?
Well, it depends on the document. You can focus in one. The thing is the deep of the analysis, yes.
Okay, thank you.
Because if you look to the example about many courses, this is just to pull together different different information. But that doesn't mean just try to have some considerable amount of textual information so you can get some insight. It's not about the number of the document.
Right, because I'm considering if I only choose one document when I build a document term matrix, so it's going to be just one row. Because the columns will be the terms and the row number will be the documents.
Well, in this case, you who is speaking is Candice?
Candice
Yeah.
Liu.
Okay. Okay. In any case, you just put your let's say why you are using one document is too much, why you are doing this. Everything must have an explanation. There is no limitation. There is no strong thing that because you did just one document, The thing is the analysis that you prove all these text analytic approaches we are doing, which is frequency, stemming, all these techniques, you master them and you can explain what you did in your document, and then you can give recommendation. If you feel that you really need two documents, you can put two documents. I don't understand if there is a problem to put two documents for you or what.
Mm, no, I'm just thinking, weighing my options.
Okay, weighing in options, just try to give some powerful analysis. If for the analysis you feel that you need more document, you put more document.
Okay.
Here, let me put, you guys already have advanced. You are almost at the end of the program. I don't want to put too much restriction. What I want is that you devote the time, not in the detail that this is not exactly this way, doesn't look exactly this way to match this and the other. Just use your analytical thinking, understand what the purpose is. And the purpose of the first assignment is to show the basic text analytic, let's say, processing you can do to a text and extract some insight, and being able to find something useful by frequency, by all this back of token approach with the available techniques, do the analysis and make recommendation, limitation, recommendation, what else can be done, more documents, because the same Watson, which I just showed exploring the tone analyzer, if you put more extensive text, what you are going to get from Watson is more insight. You know, when you put very small text, and even some of the services there, they require at least, there is a minimum text which is needed in order to get some insight, you know, because it depends of the approach and algorithm behind. So there is no limitation I would like to put to you guys. Use whatever you have learned up to here and show that you have grown as an analyst and you can analyze textual data with this approach of back of token with the different approaches, and you understand what are the different methods, what is the purpose of this different method, and then practically you apply this different method to the text of your choice. Now, it's one text, two text, three text, it's up to you. The thing is, if one text is not enough to actually get something, you will have to get more than one. Okay?
Okay, thank you.
Okay. I think this kind of questions are helpful for everyone. So let's see. Oh, 65 for document. Well, I don't know if you can manage this. Um, well, I don't think it's necessary, but if you feel, uh, um, I don't think 64 document is actually necessary, Jerry, you know. Someone is asking for a text of your choice. They are posted in the classroom. And it's named, I'm going to go shortly to tell you how exactly it's named. Let's see. Let me share the classroom.
I think it's on a week 2, and it's just.
Do you know how it's named?
Oh, I can look it up.
Can you look, please? So I cannot change the screen.
Mhm.
And yeah, it's in the classroom. In week 2, right below the assignment, you have the suggested data sources.
Text options for assignment 1, part 2.
Yes, it's named
It's
text
yeah,
option.
it's
Okay.
right under the self-assessment.
Yes, it's below self-assessment. So
Yeah.
done. Okay, great. We don't have more questions. Linish, you are more than welcome. And if
Yeah,
there are
thank
more
you.
questions after that, we are going to go to them.
Sure. Okay, so good evening, everyone. So once again, I'm Linesh Tawai, one of the TAs for this Data 650 course. And let me just start sharing my screen of what we want to kind of discuss with you and give you some information about. So, before I go into some more details here, let me tell you that we are really very excited to bring this competition to you. It's based on a simple data set that is publicly available, and yet it's presented to you in a format that will challenge you, make you work independently, as you should be at this point in your degree or certification in data analytics, and also, most importantly, on a very powerful platform that is now considered a de facto standard for data analytics and data science competitions globally. And it's now even owned by Google. So it's powerfully, it's kind of supported by all the big wigs of data science, data analytics, and some of the universities, and both, and that you'd be very happy to know that UMUC has been supporting it via one of the few universities departments that's been kind of using this platform. So you're getting the best of the best, and we want to make sure that you really make use of it and use it to your advantage. Um, and then just going into the competition details. So it's a link has been provided. Some information has been given to you. Remember, the whole idea is to ensure that you work independently as much as you can, and as you would work, outside once you're done with this course, right, at your workplace or wherever. So, but at the same time, there's a lot of information that has been provided on this website. So there's a link that is being shared that will bring you to this landing page. One of the things that will be required is your login information. And I know some of you are already aware of Kaggle competitions. You've got a login already established, and you worked on problems earlier. That's a great start. If you haven't so far, well, you're not far behind. It's a very intuitive platform, very simple to use, and there would not be much to really, it's not like a R platform or a Python platform it's not that kind of a, platform that you need a lot of learning. As far as the platform goes, very simple. There are very few simple, pages here that you kind of go through, and all that you need to know is working on your data set. Um, and then the good thing is you're not kind of restricted to what programming environment you want to use, right? You can use R if you're very familiar with R, you're an expert in R, or you can use SAS Enterprise Miner, or folks who have already done Python on the side. If you want to use Python, that's fine. But remember, at the end of the day, when the competition is over and then you are, the top students, one of the things we generally ask towards the end is your code to ensure that you've kind of gone through the steps, you've worked your code, and we'll be kind of going through that. So one of the things that we will ask you at the end is if you are in the top ranking, competitors or participants, we would want you, kind of compare, make sure that, you've not really gone on to use the code that is already out there. And of course, use the help, right? As you've been using for R and all your assignments, use a similar help. But, ensure that, take this as a personal challenge. Do not take this just to kind of gain those 2 points that, Professor Korcheva has mentioned. Yes, it's important, but, folks, I would tell you that, this is something that you want to get on. Test yourself. Now, no matter what, I mean, it's not just about, I know, Will, you have a question. I'll just get to it. Let me just finish this point. Um, but, but yeah, test yourself as much as you can. Accuracy is important. Winning may be important, but at the same time, this is going to test yourself. This is the time to test yourself to say, okay, can I take a data set? Can I just complete the whole cycle of, going through the analysis, submitting my analysis, coming up with the results and all that, right? So, okay, Will, over to you. You have a
Hi,
question?
Professor. Yes, Professor. Thank you. My question is this: if I'm running, say, typically 20 hours a week of study per class, how much time should I plan if I decide to go forward with the competition?
Well, great question, and I was just about to get to that. This competition is, as I said, is a very simple data set, like you would get for any of your assignment, but it is going to give you like 2 months, 2 whole months to complete this. And this is also an optional thing, which is not part of your curriculum. Even if you just skip this completely and just work all your assignments and everything, you're still doing the 100% of the coursework. This is an optional, an addition that may help you, that may boost your grade, that may boost your, confidence in kind of working through. So if you ask me how much time, well, as whatever additional time that you may get, it could be an hour a week or an hour a day. Just put to it. Maybe you will be just completing it very soon if you just start with it now, or you may want to keep it to the end where when you think you will find some time. But if I were you, Will, I would just start slowly working through it, see whatever I can get through, even the basics of it, right? Just the basic of, kind of quickly working through the data set, running through all the steps, and see what I get back and what I get in as a result, right? That will still be good to, go through the whole step and get to some point of completion rather than, just kind of waiting toward the end when there's going to be a lot of work to be done because, as you know, as professors have already shared with you all, this is a very fast-paced course. Does that answer your question, Will?
Oh, absolutely. Thank you.
Okay, cool. So as far as going back to the link that has been provided, once you sign in, you'll have to establish a login here on Kaggle. If you have one, that's fine. Um, if you don't, you'll have to establish a login and try to use your student ID if possible. If not, that's fine too. But you'll have to provide me those details so that we can identify you correctly because you'll probably come up with some usernames that may not be as same as what you have in the Leo classroom. So the first thing that you would come up and once you log in is this rules information, right? I mean, there's certain rules to follow about the model building process. You would be the only person per part, the only person to work on this. So there's going to be one account per participant. Please, no sharing amongst the teams or outside the team. There's not going to be a team formation here. There's no team mergers, so that team limit is one. So there is no question of merging, no question of code sharing. And the good thing is you have a flexibility to submit a maximum of 10 entries per day. So, if you work on something, you want to keep working on it and putting the code up here and with the results. Actually, what you're going to be submitting here are only your results, the submission file. And that file is going to come up with, what the score is. And I'll show you what it looks like if you haven't seen that before. And you would be able to select your 5 final submissions for judging. Now, what does it mean by 5 final submissions, right? Every time you put your results in this competition, only 70% of your final, all that submission is going to be, really graded automatically at the same time. The 30% remains on the last day of this competition when the competition closes. So it's good just to make this little more, not challenging, but very interesting, right? It's a very interesting concept that, you are kind of working through, and being tested for only 70% of the result set that you provide. The next 30% will be kind of done on the last day of the competition or after the competition closes. So you have 2 full months, um, and you want to just begin and as soon as possible. You'll have to accept all the rules, which also states that you will be, providing your solution in the best format possible, whether it's an R code or a Python code or the diagram from the, from the EM Miner, so from the SAS Enterprise Miner. So you should be ready with that information whenever it's asked. The rest of the rules are pretty much similar. It's a template that's being used from Kaggle. So you would see some verbiage here which is pretty standard. Not going to go through this all, but you may want to read through it before you accept it, so you know exactly what you're being asked for, what are some of the rules. As far as the data set goes and what you need to do is all kind of mentioned here in some of the pages that it would come up when you log into this particular website or to this competition site here. But yeah, and this data set may be even familiar to you. Maybe you would have used it in the past. It's good. I mean, this is one more test for you to see if you can do that independently now. But as simple as it's a car data set that has got some specifications mentioned, and based on those specifications, you would predict whether it's an acceptable car, it's unacceptable, it's in a very good condition. So that's what the whole idea is, to kind of predict that what is the class of the car based on certain specifications that has been provided. The evaluation, the evaluation is going to be the confusion matrix that will kind of give you the accuracy, right? So pretty much the evaluation that's going to be followed. It's a multi-class classification accuracy, which indicates that there is just more than a binary result, right? It's going to be a string here, which is kind of shown here. See the following example: the car ID and the class, and there's some certain classes here, like as I said, acceptable, unacceptable, very good. So some of the classes that are kind of mentioned here, and the submission format is also being provided to you. I believe there was a question here again. I believe there's a question about some other universities, but I did not see the whole entire, the question here. So can someone just tell me what the question is? Tom,
The
was that
question
you?
is, are other universities involved in this competition, or
Not
this one strictly for people of UMUC?
excellent question. There are very few universities involved. Right, as just a couple of months, a few months back, there were only 7 or 8 the top universities that were involved here. As far as this competition is strictly built for you, so please do not share this link with anyone outside of this course or class, because this is just strictly meant for you. Okay, and we've got ourselves involved into this, and I mean the UMUC, and just to provide this competition for you. So this is a good way to kind of it's still restricted, it's still private. At the same time, it gives you the benefit of this entire platform. Does that answer your question, Tom?
I don't see more questions.
Okay. All right. So
Yes.
is this competition analysis of big data? Well, this is of structured data. So, this is not truly the text type of data that we were talking about so far, or what you've worked on assignment one. This is kind of structured data, but it gives you the ability to go through the whole process or the cycle here. So, um, yeah, get back to kind of working what you've done through right from your first coursework or through this coursework here. Whatever you've learned, you would be able to apply.
Yeah, this is
Okay.
just like culmination, everything you have studied up to now in the program, and it's not directly related with big data analytics, but it's the culmination of what you have studied, so it's the right place for your accumulated knowledge to put in this combination.
Um, so here's the data page here that gives you all the data. It also gives you description. Remember, every time there's a lot of information being provided to you, so that you would have less and less questions. Because as I said, they would not want to kind of make this more like an assignment and support you in an assignment form, because we want you to work independently, and so all that information that could go in is already provided here, like for data sets, what the problem is. You could even discuss amongst yourself. I mean, but once again, keep the discussion more to the concepts, or more to how you want to work upon, rather than just trying to solve the problem. Do not make this more like an assignment, but more as something that could be given to you at work, right? Where you could discuss with your colleagues and discuss the situation or some of the concepts. So there's a discussion board here available. Make sure feel free to use this discussion area. As far as the submission goes, you would be coming to this page very similar to this, where you would be asked to kind of submit your code, and as soon as you submit, you come up with a score here. As the score that's that you want to kind of get to the better score here. This is just a benchmark. Like if I just randomly just put something in there, what could I get? So I could have put up something like a benchmark here, and this is also the area where it tells you that this leaderboard is calculated with approximately 70% of the test data. The final results will will be fetched on the other 30%. Okay. But having said that, I don't want you to restrict yourself if you do not understand something here, or if you need any technical support, something's not working. You know, both your TAs of this course, Yelena and myself are available to help you out with that. Okay, so this is just some information. The link has been provided to you already. The computation is live at this point. It ends on the 16th, but I would suggest that whatever the last and final entries you have, you complete it by the 15th of April, which is a Sunday. So the end of the Sunday, you may want to complete all your entries, because the timings that are mentioned here are in the UTC time zone. So you would want to kind of just complete it as much as possible on 4/15. But it has still given you more than 2 months to complete this competition, which is kind of very typical with any Kaggle competition. Anytime between 2 to 3 months or 4 months. But unlike all the other Kaggle competitions, which gives you very challenging data set, we are presenting you with a very simple kind of a data set that will help you to kind of go through this entire process, because that's the major motivation here. Okay, with that, I will kind of now open up for any questions you may have.
And question can be regarding anything, regarding everything we have talked. I just want that you understand that you have access to so wonderful resources, starting with the cloud, and moreover with this advancement that IBM put already, that was not available a year ago, the Watson application, the Watson services in Bloomix, so we can use them for free. This is just wonderful to explore. And let me tell you, there are many big data approaches we are going to use in this class. You understand this is training, and you understand how fast everything is changing constantly in this dynamic world. Everything is evolving. So there are certain things which are approaches which are very important, but the tools themselves, they change constantly. The same R version all the time are changing. So this is the simplest thing. Not to talk about the new tools which appear to deal with managing big data, with extracting insight for this different type of big data. This constantly change. So you have to take this as training with the most relevant tool at the moment.
Okay, no further questions. I will hand it over back
No, I
to
think people
Professor
is
Jeff.
tired already. We have been almost year and a half here, and everyone has worked a full day. Say, I understand this, but we still have time in the classroom to answer any question you may have. And if there are not more questions right now, I'm just going to stop recording.